Hey guys, Mr. Isley here. So we are on to lesson number 7, which is all about finding the axis of symmetry and the vertex of each quadratic function without graphing. So we talked about the processes in lesson number 6, and so that is what we are going to go through. So the first thing we want to do when we're going to do this is we're going to find the axis of symmetry. But I think even more important than that is we need to be able to identify the A, the B, and the C. Because remember, when we're talking about these, we're talking about functions that are in this form. F of x equals ax squared plus bx plus c. So we want to identify those three things, the A, the B, and the C, including the signs that are in front of them. So let's take a look at example A and let's identify those things. So on example A, we've got f of x equals 2x squared plus 8x minus 1. So what is my A? Well, when I look at this, my A again is always found in front of the x squared. So this would be my A right here, positive 2. Well, what's my B? Well, again, B is always found in front of the x, and it is a positive 8. So there's B. And then what is my C? Well, it's at the end, including its sign, so negative 1 is the C. So now remember, to find the axis of symmetry, we've got a very specific formula that we use, and that formula is x equals negative, and then b over 2a. So we want to plug that information into those spots to find the axis of symmetry. So again, this is our axis of symmetry formula, so just making a little note of that. This is the axis of symmetry. Right, so let's plug the information in. So x stays the same because that's what we're solving for. Negative stays where it is for the time being. Then I plug in b. b is positive 8 over 2 times a, and a is positive 2. And then I need to solve that down. In order to solve it down, I've got x equals, first thing I need to do the multiplication. So I've got negative 8 over 2 times 2 is 4. And so now I've got x equals negative 8 divided by 4, so I need to do that. And negative 8 divided by 4 is negative 2. So x equals negative 2 is my axis of symmetry, and so that would be my answer. So now I've found my axis of symmetry, which is x equals negative 2. Now I can take that information to figure out my vertex. Because remember, to find a vertex, right? In order to find a vertex, we need to know the x value of the axis of symmetry. So x equals negative 2. And we are going to use that to find the y value, or essentially the f of x value. So we're going to take what x equals, and we are going to plug it back into this original function that they gave us. So this is for finding our vertex here. So we're going to use what they gave us, again, which is f of x equals 2x squared plus 8x minus 1. And we are going to plug in the value of negative 2. So really what I have is f of negative 2 equals 2 times negative 2 squared plus 8 times negative 2 minus 1. And so now I need to simplify that down. So first thing I got to do is exponents, as we've been talking about. So I've got f of negative 2 equals 2 times negative 2 squared is negative 2 times negative 2, which is positive 4. So 2 times 4 plus 8 times negative 2 minus 1. So second step, I need to do all the multiplication. So I'm going to go in and do that. So I've got f of negative 2 equals 2 times 4 is 8. 8 times negative 2 is negative 16, and then minus 1. Well, last step, addition, subtraction. So I'm going to go ahead and do that. So f of negative 2 equals 8 minus 16 is negative 8, and negative 8 minus 1 is negative 9. So when x equals negative 2, f of x equals negative 9. So that makes my order pair, reminding ourselves that this is our y coordinate of our order pair. And this is our x coordinate. So my vertex is negative 2, comma, negative 9. And that is the process for finding the axis of symmetry and the vertex of a quadratic function without graphing it. All right, so let's take a look at example B, and then we will go through that together. So example B, we've got f of x equals 3x squared minus 2x. So again, I think it's a good idea to identify the a, b, and c before you get started. So my a here in this case is this 3. So there's my a. My b found in front of the x is this negative 2. So there's my b. And c is always found at the end, but there isn't one listed here. So I don't have a c listed. Well, that really means that it's kind of like plus 0, because adding 0 doesn't change anything, so they don't list it. So my c is 0, and that's something just to kind of keep in mind. It doesn't really affect anything when we go to solve for the axis of symmetry and vertex, but just something to remember. So let's start by finding the axis of symmetry, because we need to know what that is in order to be able to find the vertex. So my axis of symmetry here, all right, I'm just going to kind of enclose this in to make it a little easier. So axis of symmetry, again, we need to use this formula of x equals negative b over 2a. So let's plug in the appropriate information. So I've got x equals negative. My b is negative 2, so I'm going to input that in parentheses, over 2 times a, which is 3. And then I need to solve that down. So first thing I need to do is multiplication. Well, I've got this double negative right here that you probably noticed. And really what that means is negative 1 times negative 2. So I can go ahead and get rid of that. Negative 1 times negative 2 is 2. And 2 times 3 in the denominator is 6. Well, now you may say, well, I already know that 6 doesn't go into 2, so do I turn it into a decimal, or what do I do? Well, remember, as we've talked about, we don't turn it into a decimal, but we do want our fraction reduced all the way down. So do 2 and 6 have something in common? Oh, yep, they do. They both are divisible by 2, so I'm going to divide them both by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So x equals 1/3 would be my axis of symmetry. Well, again, once I've got my axis of symmetry, I now have what I need to find my vertex, because I need what x equals to be able to figure out the y-coordinate of the vertex, or the f of x coordinate. So again, just a reminder, all we do here is we take what x equals and we plug it in for all the x values in the original quadratic function. So what I've got is f of 1/3 is equal to 3 times 1/3 squared minus 2 times 1/3. And you may say, wow, man, I don't really like working with fractions. Well, unfortunately, sometimes we have to. So we're going to work with it as is. So first thing, again, got to clear that exponent. So 1/3 times 1/3. Well, remember, that just means we multiply the numerators and the denominators. So 1 times 1 is 1. 3 times 3 is 9. So 1/9 is what that equals. So I've got f of 1/3 equals 3 times 1/9 minus 2 times 1/3. So now we need to do our multiplication. Well, 3 times 1/9, if we remember correctly on how this works, all right, we've got 3 times 1/9, and when we're multiplying a whole number, we can put it over 1. And then if you remember, we can do our cross simplification to reduce numbers and make it easier. I know that 3 and 9 have a common thing of 3, so I'm going to divide each by 3. 3 divided by 3 is 1, and 9 divided by 3 is 3. And then I can multiply and get 1/3. So I've got f of 1/3 equals 1/3. And then I got to do my other multiplication, which is negative 2 times 1/3. So again, I'm going to move up here just to have this worked out. Negative 2 times 1/3. Well, again, can put that over 1. And nothing to cross simplify, so just multiply straight across. Negative 2 times 1 is negative 2, and 1 times 3 is 3. So negative 2/3. So essentially what I have is 1/3 minus 2/3. And as you probably know, they already have common denominators. So I've got f of 1/3 equals 1 minus 2 is -1, and denominator stays the same. So when x is 1/3, my f of x is -1/3. So my final answer here, my ordered pair, would be 1/3, comma, -1/3. And there is where my vertex is going to lie. All right, well, I'd encourage you to try example C on your own, then check your answer with mine. So let me move my paper up a little bit so we can see this fully worked out. All right, so we've got g of x equals x squared plus 6x plus 5. So again, I would encourage you to figure out your a, b, and c. Now, in front of my x squared, I don't have anything listed, which really means that my a is 1, as we've been talking about. So there's my a. My b in front of the x is a +6, and my c is this +5. So let's go in and find our axis of symmetry. So again, I'm just going to kind of label these to make it easy to know what's with what. So axis of symmetry, again, we use this formula of x equals -b over 2a. So let's plug in the appropriate information in the right spots. So we've got x equals -b is 6 over 2 times a, and 2 is, a is 1. Then we need to simplify it down. So first thing we do is that multiplication there on the bottom. So I've got -6 over 2 times 1 is 2. And now I need to do the division. So -6 divided by 2 is -3. So my axis of symmetry is x equals -3. So now again, I can use that information to find my vertex. So my vertex, I just simply plug the x value into the original function and solve to figure out what does it equal, and that becomes my y coordinate of the vertex. So my original function, g of, and again I'm going to plug -3 in for x, is equal to -3 squared plus 6 times -3 plus 5. And then we need to solve that. So g of -3, got to do my exponent first. -3 times -3 is +9. Plus 6 times -3 plus 5. Now I need to do my multiplication. So g of -3 equals 9. 6 times -3 is -18, and then plus 5. So then, last step, do the addition and subtraction. So moving from left to right, 9 minus 18 is -9, and -9 plus 5 is -4. So again, when x is -3, the outcome is -4. So my final answer here would be a vertex of -3, -4. All right. Well, if you have additional questions on that one, please let me know. Otherwise, continue on and try example D on your own, then check your answer with mine. All right, so again, let's start with the axis of symmetry, but before we do that, let's figure out what our A, our B, and our C are. So I see that A is a -1/2, that's what's in front of x squared. I see that my B is a +7, that's what's in front of just the single x, and then my C is this -4. All right, so let's take a look then, and let's recognize here, all right, what's going on. So we've got axis of symmetry first that we've got to find what x equals, and so we use our formula that we've been talking about. Goodness, keep breaking my pencil. Which is x equals -b over 2a. And let's plug in the appropriate information. So we got x equals -b is 7 over 2 times a is -1/2. And then I need to solve it. Well, we start with the multiplication in the denominator. So -7 stays the same over 2 times -1/2. Well, again, if you can't remember how this works, 2 times negative 1/2. We put the 2 over 1. We can do some cross simplification here. Both 2 and 2 are divisible by 2, so that becomes 1. So what I really have is 1 times negative 1 on the top and 1 times 1 on the bottom. So I've got negative 1 over 1, which is just the same as negative 1. So last step I need to do is I need to reduce this fraction down. Well, anything over 1 is just itself, so I know the denominator is going to go away, but I do have this double negative here. And when you divide a negative by a negative, you end up with a positive. So this one's going to go away, the negatives are going to go away, and all we're left with is the 7. So x equals positive 7. And that is my axis of symmetry. So last step, now we need to, or not last step, but last thing we need to find is our vertex. So again, we find our vertex by taking what x equals, which in this case is 7, and plugging it back into our function and solving for that output. So what I've got is h of 7 equals negative 1/2 times 7 squared plus 7 times 7 minus 4. So first thing, as we've talked about, we need to do is we have to do the exponent. So again, I've got h of 7 equals negative 1/2 times 7 squared. Well, that's 7 times 7, which is 49. Plus 7 times negative 7 minus 4. Now we need to do our multiplication. We've got 2 spots for that. So I've got h of 7 equals negative 1/2 times 49. And you may be going, again, I don't know what that is. Well, again, just remember negative 1/2 times 49. The 49's over 1. Check for cross simplification. There isn't any, so we multiply straight across. So negative 1 times 49 is negative 49. 2 times 1 is 2, so negative 49 halves is what we come up with. And then my next one, positive 7 times negative 7 is negative 49, and then minus 4. Well, I know my last step is I'm going to do all this subtraction that's going on right here. Oops, I'm sorry, I don't know why I wrote negative 7 here. That's a little bit of a mistake on my part. So we had positive 7 times positive 7, which is a positive 49. So we should have negative 49 halves plus 49 minus 4. I apologize for that little hiccup. So as you may remember, when we're adding or subtracting anything with a fraction, we have to have the same denominator. So the first thing I'm going to do is I'm going to go in and create the same denominator for these two as I have here. So I need them both to have a denominator 2. In order for that to work, I know that, and let me slide this over so I can use that little extra space on the side. I know that 49 over 1, to have a denominator 2, I got to multiply them both sides by 2. So 49 times 2 is 98, and 1 times 2 is 2. So converting that, I've got h of 7 equals negative 49 halves plus 98 halves. And then doing the same over here, negative 4 over 1 times, again I need to 2 over 2, which is negative 4 times 2 is negative 8, and 1 times 2 is 2. So I've got negative 8 halves. So then once I'm here, I can now combine those across. So here we go, h of 7 equals negative 49 plus 98. Well, I know that that's just double 49. So really that's just going to cut that in half. So I'm going to have positive 49 halves left over. Negative 49 plus 98 is positive 49. And then the denominator stays the same. So 49 over 2 minus 8 over 2. Well, 49 minus 8 is 41. So 41 halves is what I'm left over with. So all of that means, again, when my x is 7, my output is 41 halves. So my vertex on this one, though not pretty, is 7, 41 over 2, or 41 halves. All right, and so that's all we're doing to begin our next worksheet number 2. So if you have any additional questions on this process for finding the axis of symmetry in Vertex without graphing, please let me know. Otherwise, you should have what you need to do the first 6 problems of worksheet number 2.